In lesson 4-7, we're going to be talking about similar polygons. The word similar is a specific word in math that is very specific, describing the two different shapes. So a polygon is a shape that is created by line segments. So circles are not included in this. So we have rectangles, parallelograms, trapezoids, and things like that. So we're going to identify similar polygons and find missing measures of similar polygons. So when I say similar, that means like any square would be similar because all of the angles are 90 degrees. So if and then all the sides could be proportional in length if we look at two squares. So anyway, going back here to polygons. We're talking about squares, rectangles, anything with a line segment, and there can't be any gaps or any overlaps with the line segments. So similar is a specific word that we'll get into on the next slide. Corresponding parts, again, we'll talk about that on the next slide. Congruent is a word that also means equal. So if two sides are congruent, they are both the same size. And a scale factor would be, if this square is smaller and then this square is double its size, the scale factor would be times 2, or there would be a scale factor of 2 to go from this shape to this shape. And we could say that these squares are similar because all the angles are 90 degrees. Maybe this was 1 centimeter and this is 2 centimeters, so to get from here to here would be a multiplying by 2. And corresponding parts would be, well, this side is corresponding to this side, and this side, we'll mark it with 2 marks, is corresponding to this side. And since this is a square, actually all sides would be corresponding, but just for this example, they're corresponding like that. So like when we look at triangles, you wouldn't have necessarily all congruent sides like in a square. So for here, like A is corresponding to X, angle A, and angle X, and you can see that because it only has one line in the corner. So those lines represent that those two angles are congruent. Therefore, angle A is similar to angle X. Or and this symbol right here means similar. Actually, angle A is congruent to angle X. And angle B is congruent to angle Y. Angle C is congruent to angle Z. Therefore, triangle ABC is similar to triangle XYZ. So notice it's just one squiggly line. That line, that symbol means is similar to. This line right here means is congruent. So angle A is congruent to angle X. So if you learn the symbols, you wouldn't necessarily have to write quite as much. So A over B, that means this line segment right here, the line segment matching the 1 line and the 2 line, is proportional to X over Y. So that's why they put those two together, because we can make a ratio to discover the scale factor. Because as you can see here, this one is larger. So let's say, for example, this was 2 units. And this one was just 1 unit, well, that would be 2 over 1, which would be a scale factor of 2. So getting into an example problem here, it's asking us to determine whether these two triangles are similar. Well, first thing you need to do is you need to look at the angles. Well, this is a right angle and a right angle, so they are congruent. All angles must be congruent, and sides must be proportional in order for us to say that it's similar. So we have angle F and angle K are congruent, and angle J and angle E are congruent. The way we know that, we don't have to get a protractor out and measure it. We can see the lines, and that means that they are congruent. Now we need to match up corresponding sides and write them all as ratios to see if they're equal. So this side right here, side 4, ED, line segment ED would be 4, and we're going to put that over corresponding side JH, which is 5. Okay, So these two are corresponding because they are between the 2-line and right angle, 2-line and right angle. And we want to see if that's equal to, now since I put this triangle on the top with 4, I'm going to keep all of these numbers on the top. So I'm going to say 3 over 3.75. And then I'm going to say 5, that needs to go on top, 5 over 6.25. And now I need to determine whether or not all of these ratios are equivalent. So if I need to, I can get a calculator out. And I know that 4/5 is going to be equal to 0.8, so I can write that down right away. It's going to be easier for me to determine if they're equal by finding their decimal equivalent. So 3 divided by 3.75, and that also equals 0.8. So if the last one equals 0.8, then I know that this is a similar triangle pair. So I need to do 5 divided by 6.25, and that also equals 0.8. So all of the ratios are equal to 0.8. So going from this triangle to this triangle, it increased, and the factor here is 0.8. So what we can say is that triangle DEF is similar to triangle HJK. And then this is kind of our work. This is our work to show that we proved that those things are all equal. So given that rectangle LMNO is similar to rectangle GHIJ, find M. So now this problem, they're telling us that they are similar. So since they are similar, we can take these two sides. You can do this a couple different ways. You can take the smaller shape and make that a ratio. So if you wanted, you can say 2 over 4 equals, now you have to match up the corresponding. So 2 goes with 3, so you need to put 3 on top. And 4 goes with M, so you need to put M on the bottom. And then we have a proportion. So we know how to solve a proportion. It's not really easy to go from 2 to 3. So let's do cross multiply. So we get 2M equals 12. Divide by 2. Divide by 2. Whatever you do to one side, you have to do to the other. And then we're going to get M equals 6 units. So we didn't know how long it was, and we're talking about distance here, so we do need to include units with our answer. Also, you can see that the relationship here from 2 to 4, well, that doubled. So you could have figured, well, I just need to multiply this by 2 to go from here to here. And so you could have noticed that as well. But just as long as you show me this work right here. Now, I said you could have shown this another way. You could have put 2 over 3 as a ratio. So if you did that, you'd put 2 over 3 equals, and then you'd put 4 on top, 4 over M. Notice that we get the same multiplication factors. You still get your 2M, and you still get your 3 times 4, which is 12. Everything's still going to match up. So the idea here is just make sure that whatever you decide to do to match up your corresponding parts, make sure you keep everything lined up. So in this case, we did 2 over 4, and so we had to do 3 over M. We kept it all matching. And then in this example, we did 2 over 3, so we had to do 4 over M. So you always have to make sure that the parts match up. That's why we say corresponding parts. So if two figures are similar with the scale factor of A over B, then the perimeters of the figures have a ratio of A over B. So if we know a little bit about the sides and the ratio, so here these two, they have a ratio of A over B. So that means the perimeter also has a ratio of A over B when we find out these two perimeters. So let's say that this one was 1 and this one was 2, and the perimeter of this one was 8 centimeters. Well, the perimeter of this one would then be 16 centimeters because it goes from 1 to 2, so it goes from 8 to 16. which makes sense because, you know, if this one was 1, you know, it's going to double here. So obviously the perimeter is just talking about distance around. So if those lengths of the sides are doubling, obviously the perimeter is going to double as well. So for an example with that, a polygon has sides 2.5 times as long as a similar polygon. The smaller polygon has a perimeter of 42 inches. So what is the perimeter of a larger polygon? So just for an example here, I can go ahead and draw a rectangle and then draw a larger rectangle. And we know that to get from here to here, we're doing a factor of 2.5. We're multiplying by 2.5. So it says the smaller polygon has a perimeter of 42 inches. So we want to know the perimeter of the larger polygon. Well, if the side length is going from, if this was 1, this one would be 2.5. So we need to multiply by 2.5. So we take our 42 and we multiply by 2.5. Well, 42 times 2 is 84. And then 0.5, half of 42 is 21. So I'm going to get 105. So the perimeter of the larger polygon is going to be 105 inches because of the scale factor of 2.5 being multiplied to get from the smaller polygon to the larger polygon. That's all we have for examples for today, lesson 4-7. So if you'd like to see some more examples, please watch the online personal tutors, and also be sure to check the step-by-step homework helper located on Moodle.